Hello, this is Joe Montano. This is a video about combined fooding. Before talking about combined fooding, it's very important to first start with fooding itself and why it is and how and why it's important. Fooding is the lowest part of a construction. Um, it's below the foundation, uh, which it helps as a reinforcement for the foundation and also the part that supports the loads given by the columns on the foundation. Now that we know how what is footing, now we can start with the combined footing part. Combined footing, the main difference for combined footing from other footing is the footing itself most of the time is just comprised of one column, and distributes just the forces for just one particular column, and there's a specification of the amount of area that is needed for raised footing depending of the grade of the soils and the grade of the soil and different other aspects that may be. Um, combined the main difference between combined footing and the other footing is that combined footing instead of just one column is used to have two or more columns. How this works is very simple. There are two main types of combined footing. The one is rectangular footing, rectangular combined footing. The difference between rectangular combined footing and rectangular footing itself is mostly uh, the columns and how they work. The thing is about rectangular combined footing is that the columns are square, but there isn't a need for the area to be distributed on the center. However, for rectangular normal footing, the column is rectangular to have the same center of gravity as the footing. The second type of combined footing is trapezoidal. All right. This third one is the trapezoidal footing. It's mainly used in order to distribute the mass to one of the columns more than the other. Each have different uses. That is mainly the reason why sometimes we use the rectangular footing and sometimes we use the trapezoidal footing. The reasons to use the combined footing instead the normal footing is, for example, columns are close to each other. When columns are close to each other, each column should have a certain amount of footing area per footing, which means that if the columns are close to each other, it's just better to combine the footings and have a great amount of area per footing having the two columns. The second reason will be the case of having a soil with really low bearing capacity. In this case, we just enlarge the amount of area per frame that we have, which will be enclosing more columns. Um, so, because the amount of area needed for footing is better to having two columns in the same footing and have the forces and the load distributed evenly between more columns. The third purpose is the most is the fact that sometimes columns are really close uh, to the boundary line of the side, and this creates a problem in which it's not possible to continue excavating or extending to the side, in which in this case will be used a combined footing to have more of this load get it evenly to another column as well. Um, the main purpose of using the combined footing is that we distribute and how it works, because it's very interesting. It's just distributes the forces between having the same two columns and take the center of mass and, well, the center of gravity of these two columns, and take the footing, the combined footing, and the combined footing should have the same amount, not the same amount, but the same center of gravity as the two columns combined. In normal cases, normal buildings, like I said, when columns are close to each other, so it will use a normal rectangular footing, because the columns close, they are close to each other, they should have a relative same amount of load that each column have. So the force of each column will be in the center, and the area that each column have should be around the same. That's why it's rectangular, to keep the like the same amount of area per column, which will create that the center of gravity will be in the same place as the center of gravity of the footing. In the case, like I said before, there are sometimes that the columns are close to the building boundaries. And the problem when the column is close to a building boundary is that there is more load at the end of the building boundary than in the middle of the building. Why? Because it's where other walls and other forces from the corners, that is the dead load, are situated. So this column, for example, if we take this is the the construction boundary, this column will have a greater force than this column, in which the center of gravity of this, let me put this better, in which in this case the center of gravity, when we combine these two columns, will be not the same, will be more close to the lowest one, because there is more load here, so we need to make it into the middle. So how combined footing repair this? Using trapezoidal footing. So, and when we use trapezoidal footing, then it will create more amount of there will be more load in this side from the footing itself. And let's say just 1 hour of force in here, which may create that the center of gravity will be again in the middle of both columns, meaning the force will evenly distributed uh, in this case, making both columns being more resistible. And that will be all about combined footing. And the thing about this topic is that it's very interesting in how footing is affected for different reasons, about the distance between the columns, the amount of area that is needed. For example, a big, let's talk about skyscraper. Why we will use combined footing for a skyscraper? In this case, not because the columns are close. Like for example, let's think like this column are totally separated. In this case, even though these columns are totally separated, because the load for a skyscraper is so high, that means that there's a bigger need for a bigger footing in this case for the same column. Which, if you take the amount of load that is the area that is needed, then you will find out that most of the time these areas will just intercalate to each other, which the using combined footing we can take this load and make it evenly. This is mostly for really high load buildings, and also the fact that if the soil around also is have a really low bearing. So that will be all about combined footing. Thank you.